Today we're looking at areas of prisms and cylinders, and we'll find that the area formulas for these are very, very much alike. So we have two different things that we're looking at. We'll have lateral area and surface area. Surface area will be the area of everything for the prism or cylinder, whereas the surface area will be everything. The lateral area will just be the up and downs without the two bases. So just a quick reference, if we had a cylinder, right, it might look something like this. Or if we had a prism, it might look something like this. That should be a dashed line as well, sorry. All right, so our bases are the two triangles, or our bases are the two circles. All right, so we have might have our prism or our cylinder. So we have lateral area, surface. And the difference between lateral area and surface area is the lateral area does not include the two bases, so it won't include the two circles on top and bottom. It's just the round part for the rest of it. And again, here, lateral area would be the three rectangles that form this triangular prism, not the two bases, the triangles themselves. The surface area would be everything. All right. So for a prism, our lateral area is the perimeter times the height. And the surface area, again, is bigger than that because all we do is add the two bases. So it's the lateral area, but usually I just like using pH again. So you can use lateral area plus or pH plus 2 times the area of the bases, or each base, right? The bases are the same here, which is what allows us to do it. For a cylinder, the lateral area is 2 pi RH. And what I want you to notice here is that this is not a new formula. 2 pi r, right? 2 pi r should look familiar. That is the circumference of a circle, right? And that's the same thing as being the perimeter, right? So this is really circumference times height or perimeter times height. These are the same formula, just that when we deal with circles, with cylinders, that 2 pi r is always what we use. And for a prism, it could be triangular, it could be rectangular, it could be a trapezoid, it could be a number of different things. And so we don't have a set thing that we'll use there. The surface area is, again, the same thing, 2 pi RH plus 2 times the base of the cylinder. The area of the base is pi r squared, and we have 2 of them, right? And that should give us our basis for everything that we're going to do today. So let's take a look at a few examples. If we had a triangular prism, actually it's going to be a triangular right prism. I'm not much of an artist. I think you guys know that by now. We're going to pretend it looks like that. It has a side of 4 meters, 3 meters, and 10 meters. And we want to find the lateral area and surface area, right? So again, the lateral area is not going to include the two bases. So it is just, lateral area is the perimeter times the height. A quick reason on why it's perimeter times the height is there are 3 rectangles formed, right? One of them is 3 by 10, which we can see here, right? One of them is 4 by 10, that's the bottom rectangle. Then we have a third rectangle, that's that back one that's kind of hidden, right? And it is going to be, well, we have a 3, 4, 5 triangle, right? It's going to be 5 times 10, right? Well, if you take 3 times 10, 4 times 10, and 5 times 10 and add them together, right, that is just 3 plus 4 plus 5 times 10. And that is the distributive property that would allow us to do that, which puts us back to perimeter times height. Our perimeter of the base, and that's the perimeter of the base, 3 plus 4 plus 5 is 7 plus 5 is 12. So we get 12 times 10, which is 120 meters squared. The surface area is going to be that 120 plus the area of the bases. That's 2 times area of a triangle is 1/2. The base times the height, that's 3 times 4 or 4 times 3. The 2 and the 1/2 cancel, and we get 132 meters squared. Second here, we'll look at a rectangular prism. Let's see, start with the rectangle out front, I think will be easiest. Come up a little bit. Oops. When you draw them, it is best to try to make opposite sides parallel. So even though this is technically a rectangle here, it looks like a parallelogram for our purposes, right? And you want to make this side parallel to this one, this side and this side parallel. Again, not perfect, and it's okay to not be perfect for what we're doing. But I do think that drawing the diagram is probably good for you. We have 10, 15, and 8. And we're going to say all of these are inches. All right. Again, lateral area is everything but the bases. This can be a little bit tricky to try to figure out what the bases actually are. Sometimes it will be very, very clear. For a rectangular prism, it's probably the toughest because you could make an argument that it's any of them. However, generally here, I would think that we're talking about this side and this side, though it would make sense if you thought it was this one and this one. So we're going to do these two as our bases. That will change your lateral area. However, your surface area will not be affected. If I ask a question like it on the quiz or a test, I will try to be very clear about what sides I think, or what sides I want you to find using this and which sides are the bases. So what is our perimeter? Well, our perimeter is, this side is 10, this is 10, this is 8. So the perimeter of the base is 10 plus 10 plus 8 plus 8, which is 36. And the height is 15. 36 times 15 is 540. The surface area is going to be that lateral area plus the area of the bases. Each base is 8 times 10. So we have 2 times 8 times 10. Notice this time it's a rectangle, so we don't have that 1/2 that we did last time. That was because that's how we find the area of a triangle. And that is 80, 160. 160 plus 500 is 700. All right, we're going to look at 2 cylinders. This is going to have a radius of 4 and a height of 12. We'll call them meters. So our lateral area is 2 pi RH, right? And notice, again, that's just the perimeter, the circumference times the height. This is, the radius is 4, so we get 8, well, 2 times 4 times the height of 12 pi. In past years, typically I have you leave it in pi, but given our situation this year, you are going to give answers to the nearest tenth. I got 301.59, which means I'm going to round up to 301.6, and that is meters squared. Now, depending on how careful we want to be, we might go back and use 96 pi here. Typically what I would actually do. And the reason there is just so that if we're not rounding twice with this pi and this other thing that we're going to use over here, which is 2 pi r squared. R is 4, so we get 16 times 2, 96 pi, 96 pi plus 32 pi. That gives us 128 pi. And then rounding just once rather than rounding twice, where we might get off by a tenth somewhere, about 402.1 meters squared. Chances are, if you didn't do that, rarely is it going to actually affect your answer, but it is better to do exact until we're rounding at our answer. And last one. This time we have a diameter of, sorry about that, diameter of 8 centimeters and a height of 20 centimeters. This might be a good one to pause. Just recognize that this is the diameter, not the radius, right? So our radius is 4 centimeters. And you might pause it and actually try to work this one out. All right, so we have our lateral area is 2 pi RH, that is 2. R is 4, H is 20 pi. And that is 8 times 20, which is 160 pi. And 160 pi is about 502.7 centimeters. We round up, it's 0.65. Our surface area is 160 pi plus 2 pi r squared. R is 4, that's 16. That gives us 32 pi again. 160 pi plus 32 pi is 192 pi. 192 pi is about 603.2. And we are in centimeters, oops, squared. And that should do it for us.